In question 12, we have a rocket being fired up into the air. We've seen the shape of these graphs already. It's going to have to come down at some point, so it's going to go up and then at some point start dropping. This one here, the height is given by 10t minus t squared, and we're asked to draw a graph to represent the height of the rocket during the 10-second flight. So obviously it comes back to ground, and you can see 10 10 is 100, minus 100 is 0. Starts at 0. So we have 2 points straight away on our graph, 0 0 and 10 0. 1 will be 10 minus 1, which is 9. 2 will be 20 minus 4, which is 16. We see symmetry here. 3 will be 30 minus 9, which is 21. We have another 21 here. Will the next number be 24? Let's see. 4 will be 40 minus 16, which is 24. So it is. We have symmetry now. So we get the rest of the answers. This has to be a 9 based on 9 being in between 0 and 16. Let's double check. It will be 10 9s 90 minus 81, which is 9. But you all know this at this point of quadratics. So let's put our points on 1 9. Should be able to draw this one accurately. 1 9, 2 16. Then we have 3 21. Just take your time with them. Then we have 4 24. And we have 5 25. Which is here. And then we match them off. Over 2, down 1. Over 2 and down. Should match off there with 6. And then 16 is 7. Sorry, 8. 7 is 21. Which I just missed by. I think they're in the right positions. Do the top first. And then connect them down. You can't use a ruler. That's the one rule here. You can't have any straight lines with a quadratic. Just as best you can. Draw them up, down and down and down until we get back down to 0. And we're asked to find either f of 2.5 or whatever they call the function. So let's estimate a 2.5. Have we done an accurate graph? We get the exact answer before we go left. So 10 by 2.5 is 25 minus 2.5 squared, which is 6.25. 25 minus 6.25 is 18.75. So let's just get 18.75. That is, it matches off pretty accurately with where we were. So that's our estimate. We know it's correct. Is it meters? It is. So the highest point we can see here. If we wanted to use calculus, we could at leaving cert, but at junior cert just has to identify it. So it's the point 525. The slope joining these two lines between 6 and 7. So what do we know between 6 and 7? It's coming down. So the change in y is 3. So it's negative over the change in x, which is 1. So the slope is minus 3. The rate of change. Would you expect the line to be joining 7, 21 to 8, 16 to be steeper? We'd say yes, it's falling quicker. So between 6 and 7, let's join up these points here. So we have a 1 and a 3 between 6 and 7. Between 7 and 8. See here it's falling quicker between 8 and 9. And between 9 and 10. Let's look at all the slopes. So these are all gaps of 1. So the slopes are the change in y along here. So the change between 7 and 8 is 5, you can see here. Between 8 and 9 is 7, and between 9 and 10 is 9. It forms another quadratic, 5, 7, 9. Let's look 5 here, slope of 5, slope of 7, and a slope of 9, all minuses. So the rate of change as it moves down the curve. So we're going to say it's falling quicker towards the end for this bit at the end, if you want some English to go with it.